this is Ms. DB, and this is going to be a fairly short video on how to use Desmos to complete the 6.7 Part 2 worksheet. And this is on polynomial functions, graphing them. So there's some information reviewing the end behavior of polynomials. We've already talked about this, but as the function goes, as x goes to positive infinity, it'll do something, and as x goes to negative infinity, it'll do something. So this is depending on if it has an odd degree or an even degree, and then if the leading coefficient is positive or negative. So we'll look back at this as we need to. And then these are the steps if you had to graph a polynomial function by hand. Now, if you have to graph a polynomial function by hand, you're going to get an estimate at best of your graph. We have graphing technology that can graph the exact polynomial function. But for the first problem, and only for one problem, we're going to go through the steps on how you would do it by hand. So I show how to do this in Sketchpad already, and there's a Sketchpad file set up, but if you prefer to use Desmos, you can use that as well. So the first step is to figure out what the possible rational roots are, and you do that by multiplying the first and the last and taking all the factors of that. And then we use synthetic division to find at least one root. And when you find that one, then we use that to start factoring. This is all a review from other things that we've been doing in this chapter. Find out what the zeros are and put those on the graph. Zeros are on the x-axis, so you're going to put points there. You know that the function will go through at those points. Now we also need a few other points, so pick a couple in between the zeros and see what's happening. Find out what the end behavior is so that we know if it's increasing, decreasing, etc. And then sketch going through the points that you have and all that information. So here's our first problem, and again, it's cut off just a little bit, but I don't know how to move it over without missing. Let's try this. Okay, it's all right. So you're going to just do one by hand. This is if you wanted to sketch it, but I don't recommend that. That would be like the least favorable outcome. And if you were going to do it on here, just be careful and be ready to erase. I'm going to do mine in Desmos. There's options to share your Desmos graph with a link, or you can take a screenshot of it and paste it onto the worksheet. So either of those would be better options than drawing it by hand. And of course there's Sketchpad as well. So my possible roots are, the first term is, the leading coefficient is 1, and the last one is 6, so 1 times 6 is 6. So the possible roots would be plus or minus 1 times 6, or 2 times 3. Now these are all plus or minus. I'm just not going to type it each time. I'll just try 1. I'll try 1, and I'll use synthetic division. So if I want to try that the root is 1, I will factor. It would be 1. Oh, I'll just use 1. If it doesn't work, I'll do negative 1 and see if that works. And then the coefficients of my original are 1x cubed minus 2x squared minus 5x plus 6. And then, oops, I don't want it to do that. Stop making a list. And then I leave a space here, remember. And then it's hard to do this in typing, isn't it? So the 1 is going to drop down, the first one. And then I go 1 times 1. And that's 1, and I put that under the next number. And then I add negative 2 plus 1 is negative 1. And then I multiply back. Negative 1 times 1 is negative 1. And then negative 5 plus negative 1 is a negative 6. And negative 6 times 1 is negative 6. Oh, this is nice. And 6 plus negative 6 is 0. If you get a 0, that means the number you started with is a factor. Is a 0. So we have that x minus 1, the opposite, is a factor. And these numbers here tell you what the coefficients of your factored polynomial will be. Remember to decrease each of the x exponents by 1. So the first one is 1x squared. And then we have minus 1 would be x. And then the last one is the constant of minus 6. Now we're going to factor the 1x squared minus x minus 6. I'm going to take that 1 out of there. It looks funny to me. So what are the factors of negative 6 that would give you a negative 1? When you add them, we've been doing a lot of factoring, so I'm just going to check if it's these two, which I think it is. Negative 3 times negative 2 is negative 6. And if I FOIL, I would get, for the middle terms, I'd have 2x minus 3x, which is negative 1x. So this is going to work. So these are the factors. I'm actually on step 3 there. And then step 4 is factor further to find all the zeros. I already did that. Now I'm going to plot the zeros. Oh, I have to solve these for 0. So this is equal to 0, which means that either x minus 1 equals 0, or, well, it's and x minus 3 equals 0, and x plus 2 equals 0. And that means I would add 1 to both sides. I'd get x equals 1, x equals 3, and x equals negative 2. Those now I'm ready to plot on the graph over here. In Desmos, to plot points, you need a table. These are the x values. The y values of each of these will be 0 because they're going to be on the x-axis. So one point is at 1, 0. One point is at 3, 0. And one point is at negative 2, 0. Those points are now graphed. Okay, got those, got 4 done. Find some other values at some other points and plot those. Let's make a little xy table. We'll just continue in here. Let's find out where it's at x equals 0. So when x equals 0, where's my original function? I'm going to put 0 in for x and see what I get. So when x is equal to 0, p of 0, because I'm letting x be 0, would be 0 cubed. You don't really have to write that if you don't want. And then we would have 2 times 0 squared minus 5 times 0 plus 6. So we would get, lots of zeros here, 0 cubed is 0, minus 2 times 0 squared is 0, minus 5 times 0 is 0, plus 6. So it all turns out to be 6. So at 0, we get 6. So there's another point. That's the y-intercept. Let's find in between these two zeros would be, this is at 1 and 3. So let's do one at 2. Let's see what p of 2 equals. So p of 2 would equal, we're just going to replace each of these x's with 2. So we'd have 2 cubed minus 2 times 2 squared minus 5 times 2 plus 6. And we just simplify. 2 cubed is 8 minus, okay, 2 squared is 4, and we have to multiply that by another 2. That's another 8. Minus 5 times 2 is 10, plus 6. So we just subtract and add in order from left to right. 8 minus 8 is 0. Minus 10 would be negative 10. Plus 6 would be negative 4. You can double check it on a calculator. So at x equals 2, we ended up with negative 4. So you can kind of see what's happening here. It went up and then down, and then it's going to go back up in order to hit this 0. I'm just going to do 1 point on this side just to kind of see. I'll do negative, yeah, that's a little trickier. I think 2 is enough. Okay, let's figure out the end behavior. This function, the leading coefficient is 1, and its degree is 3. So the leading coefficient is positive, it's positive 1, and its degree is 3, which is an odd degree. So it's going to look like this. As x approaches infinity, the function is also going to approach infinity. So my end behavior is as x approaches infinity, my function is also going to approach infinity, positive infinity. And as x approaches negative infinity, my function is going to approach, and you can look back at the table to double check, but I think it's negative infinity. As x approaches negative infinity right here, p of x approaches negative infinity. It's going to get farther and farther down. The domain and range are both all real numbers. I don't think I asked you for that. And now we're supposed to sketch a smooth curve of the graph. Now that's one thing that you can't do in Desmos. There is no pencil tool that I have found yet. Maybe you found one. But I think that I'm just going to do it with my mouse. I think it's going to go up, down, and up. Now I don't know exactly where the min and max are. We could use that too, and we'll talk about how to do that soon. But I'm going to go ahead now and use my tools in Desmos to go ahead and graph using technology, which is how we'll do the rest of them anyway. You know what, I'm just going to call this y just so I don't confuse Desmos. Y equals x cubed minus 2x squared minus 5x. It's not yet going through my points, plus 6. Now, look at that, it's going through all my points, and I actually, pretty dang close, found the max and min, or I found the min. The relative min was close to my root of 2, not exactly. I mean my x value of 2. So these are the points. Now you can see that the relative maximum, which we'll talk more about, is right here. The relative minimum is right here. And there's our zeros, -2, 1, and 3, just like we thought they would be at. And now you can take a screenshot of this, or you can take this, share this link, and I just copied it. So my graph I can put right here. I'll just paste it in. And what that does is that when I open this worksheet that you've submitted, I am able to look at exactly this graph and see your points, and that you have everything labeled that you're supposed to, and that the graph is here and everything. Now the rest of this worksheet, you'll just skip all of those first parts and go ahead right to graphing, pasting the graph, and then you can use the graph to answer the questions like what is the y-intercept, what are the zeros, name another point, and you can answer the end behavior either from looking at the function and figuring out what's the degree and is the leading coefficient positive or negative, or you can look at the graph and see what the end behavior is doing. So you, for the future ones, you won't need the, I'm just going to leave that on there for a second. You will just go right to graphing, and then you can use the graph to answer the questions. So you can't really do these without graphing, without using technology, unless you want to go through all of the steps that we just did and get a close approximation. So look what we know now. We know that the zeros are at -4, at -3, these are the real zeros, and at 1. We know that the y-intercept is at 0, -12. We know that there is a local maximum, when you're asked to find that, on some of them you are, at this point right here, and there's a local minimum right here. So lots of information. We can find another point on the graph just by clicking like here, and it will give you the value of a point, and you can go like this and find different values. If you like nicer numbers, you can try to find one. So all right to have decimals for this too. And the end behavior, I can see that as x approaches positive infinity, the function also it approaches positive infinity, and as x approaches negative infinity, the function also approaches negative infinity. So you can answer all of these questions from the graph. And then here's the part, the last few problems are the local maximum, maxima, and minima. That's where the highest point of the bumps are and the lowest point of the bump. Now there's no absolute maxima on this one because this part of this branch of the polynomial continues forever towards infinity, and there's no absolute minimum because it keeps going towards in negative infinity. But we can find these values. Those are called the local maxima and local minima, and you can get those off your graph. All right, so use Desmos. Don't forget to share your graph either by taking a screenshot, and when you take your screenshot, include this information, please, that what you typed in for your function, or if you used a table, what you used for that. And otherwise, you can remember, you can just share the link, copy and paste it into a Word document. Even if you were printing these and doing it by hand, do this part using a Word document so that you're able to save the graphs. All right, that's it. Thank you very much and have a wonderful day.